So today's topic is, as I was talking also to my fellow friend here, it's just my experiences at the current jobs that I've had, and I try to compile some principles that basically will help us achieve organizational excellence. But before going deep into the topic, maybe you think, who's this guy? Jon already talked a little bit, but since I came to Berlin, I also was involved a lot in the software craftsmanship communities, and also I did some mentoring, which tried to give back to the community and stuff like that. Currently working at SoftGarden as a tech lead, and I tried to write something on LinkedIn and also have my blog under my domain. So if you have time, sometimes feel free to check. Also, there's a newsletter. So there are three pillars that I put up here that will help us or will guide a company to achieve somewhat an excellence in tech, let's say. First of them is CI/CD or continuous delivery. Then there are lean principles, and in the end, the three ways of DevOps. In the end, you'll see that all of these topics are really intertwined together. So I'll be repeating myself a lot, but as a conclusion, you'll see that it all evolves around the same thing. I was wondering, like most of us work in tech, and how many of you actually do continuous delivery at your company? Yeah, okay, that's same. So let's see what this is and why it's important, right? And why maybe you can push this at your own companies to go for it. Let's look back how manual releases are done. Let's say most of you also don't do continuous integration and deployments, but as you can see, it starts from the dev side where they grab a ticket and start working on it. They push it to the Git repo, but then it takes some time when the QA starts testing it. But before that, also, it requires that some ops people need to deploy it somewhere, right? And the gaps between each actor in this diagram, they're sometimes happening, right? This is, in the end, we may deliver value to the customers because we did the job and whatnot, but also that time, the time we spend on working on stuff, it's really important, right? Well, continuous delivery, or CI/CD, let's call it, in this case helps us by automating each of those steps, right? And we need to take this approach because it also helps us fail fast. So let's say a dev in their local machine, they also supposedly have automated testings, right? So they start from their own place, they run the tests, everything's good, they push the code, and there's when the magic starts happening, right? There are build pipelines that build the project with your new changes, then the automated tests run, and afterwards, if everything looks good, another pipeline would take over, which would bring the whole feature to production, right? So it's not as easy as I just explained it, but when you have the tools in place and basically automation cannot make mistakes as human errors can do, like if we do it manually, right? So there are some practices or some things I gathered. If we were to do continuous delivery, what are the benefits, right? First of all is the low risk releases. So if you know, or let's say you see the build going green, the test going green, and then the deployment going green, like you gain some confidence, right? So there is also a lower risk that something might have gone wrong. Next is you are faster. You don't need to manually check every step. You have the machines doing the work for you. If we have automated tests in place, beware, no brittle tests just to cover the code, but good tests, then it means high chances there's higher quality. So what is next is the lower costs. As we all know, machines cost less than human work, right? So people would be paid a lot more to do the QA, would be paid a lot more to integrate the code, etc. Taking all of these things into consideration, we can easily say that we would be building better products. And as of my experience, engineers like automation, so you would have happier teams. So in the end of the day, if you have CI/CD in place, it would be just one click away that you can have the deployments, or you can have the whole feature deployed to the customers and ready for use, right? And as I mentioned earlier, you basically cannot forget a step if everything's automated, right? Yeah, this was the first part, which is more technical and what we can achieve if we automate some processes. But the lean principles, as I said, CI/CD may be one of the principles inside. But what are lean principles? So this originates also not from software engineering. It actually comes from manufacturing. So Toyota in the late 80s decided to make a change. They were not being able to produce as much as they want. So there were some hiccups in the production line, and they came up with these lean principles that helped them skyrocket their production. And as we did here in the 90s and 2000s, the agile movement and stuff like that decided to take these principles into software development methodologies. So we will look into these, how they can help us in engineering. Yeah. Let's start with one of the lean principles, which is also the most important one, is to eliminate waste. And what this means is that we do not need to occupy the resources, in this case engineers, to work on stuff that doesn't bring value to the customer. So it could be a feature that one of the product managers decided to just go with it because they want to, but in the end, no one uses it, right? Or it could be a bug fix that really doesn't bring any value. So by eliminating this, we make sure that we only focus, or everyone works on stuff that is important. Putting best quality in, as we said, having automated tests, also following the practices such as XP programming, where people really go into software craftsmanship and do test-driven development, etc. So all of these ensure that the quality provided in the code is high. And about fast delivery, agile methodologies such as XP, Scrum, Kanban really ensure for us to visualize our work and actually make us able to go faster and get feedback also faster. So the time from starting to work until it's shipped, it's quite short, having in place CI/CD as well, right? The next principle I wanted to tackle is the delay in making decisions. And this is quite important because it relates to eliminating waste. Is we don't need to make decisions quite early in the process. We need to gather as much more information as possible so we really know what to bring to the table. Also, being able to go back and forth, getting feedback, we can ensure that we are not making one decision only, but we are actually flexible and we are able to adapt. And the other one is optimize the whole thing. As I said, bringing every best practice into place where you measure and have metrics for every step in the process and optimizing it. I left the create knowledge and empowering the team as the last principles that we have to focus on because creating knowledge is, I think, one of the most important principles in an engineering team because that's the only way we can keep learning and empowering each other. So empowering the teams would be when you allow them to experiment, use new tools that are not validated, let's call them, but also you allow them to make calculated risks. So give them courage to try new stuff and innovate. And creating knowledge is by allowing them to share the knowledge with each other, like there are knowledge sharing sessions between cross-functional teams. It could be organizing hackathons inside the company, also going to conferences together, also as part of team building, no? So all of these principles, when put into place, we can make sure that the company is going to the right direction. There is a DORA metrics that I also wanted to talk about. DORA is the DevOps Research Association. So they came up with these 4 key metrics that really can distinguish high-performing teams from low-performing teams. And the first metric that we'll look at is the deployment frequency, right? The number of times per day, like I don't think many company or many teams actually deploy many times a day. This is the case also in our team, but we try to deploy as much as possible, right? Whenever we can. But we'll see also at another diagram later, but the number of deploys per day actually give a really good impression that the team is performing very high. The next one is the lead time for changes. So the lead time actually is from the beginning when a feature is planned until it's delivered to the customer. So that is including also the processing time, because we as engineers only think about, okay, I take the ticket, I implement it, I push and open the pull request, that's it, my job is done. But actually when engineers are proactive and they think also the product side a little bit and also create the implementations production ready, then it means that the lead time will be shortened because you have all the things in mind. And yeah, this just increases the speed of the output. Change failure rate. So let's say we implemented a feature, we deployed it, but then the support team reaches out and says, oh, there's a bug with the fix you made or with the new change you put there. Now, that's almost every time in low-performing teams, because if you look back at the process they would be doing is they have manual checks. So people would say, okay, it looks good to me. They would open maybe a very big pull request and no one has time to read the whole files. No, we just say, okay, this is fine. Just get it out of my face. And yeah, so basically this metric is when you ship a new feature or whatever it is, what's the rate that the services go down. The last one is the mean time to recovery. So after the service goes down, there should be some processes, some tools in place that allow you to go back up, right? We know this also from life that when you go down, you need to be up and continue, but you also need some pushes, right? And usually when there are no processes in place, you don't have good monitoring capabilities, this is very difficult, right? Let's imagine there's no logging. You don't know what's going on, right? You just maybe restart the whole thing, but that's cannot ensure that it will work, right? Yeah, so here we can also see some more information about low performing and elite teams. I don't know if there's teams who deploy in like 6 months, but I've heard stories. I just don't want to believe that, yeah. But yeah, obviously, if you can deploy on demand every day, like, I don't know, there's a bug fix that you need to do, and then, okay, you've done it. Now you can directly deploy it, so the fix is there immediately. That's good enough. In my experience, at Soft Garden, we tend to use, we were using releases, right? And we were deploying like once in 3 weeks. That's not as bad, right? So it's a medium performing team, but we changed this and now we can actually deploy whenever we want. We still have some nightmares from things going wrong, because we were used to like deploy, I don't know, 30 tickets, right? So chances of something going wrong are high. I'll talk about that later, but for now, yeah, make sure to deploy smaller batches, so smaller chunks, and very soon in the process. So the lead time for changes. I don't know, if someone would tell me, hey, you need this feature to be done in like, usually product managers would say in 2 days, and you say, yeah, but our team does it in more than 6 months, I think that company wouldn't exist, right? But also being able to provide a feature or to ship something in less than an hour, I mean, it's ideal. It's almost just dream about it, yeah. But all of these things that we talked so far actually allow us to do this. And yeah, I won't go into much more details as we will share the slides with you. You can have a look at these later. So you say, okay, let's say we are somewhere in the middle. How can we improve this, right? Well, to improve the deployment frequency, just deploy smaller stuff. It could be as much as I don't know, a translation change. So you don't have to wait for it to pile up. Then when you have something real, no, just deploy it. It's more valuable when the customer sees the change rather than you have it as an open pull request. Well, to allow you to do this, if you have automated CI/CD pipelines, right? This is very easy because you just push the change and then it takes over by the machines. To improve the time it takes for you to do a change, usually what happens is, okay, this team thought I'm going to do it this way. We thought we're going to do it this way. So there are quite some silos between teams. So if we are able to create cross-functional teams that have their own domains, and honestly, just right now talking about this, we made all of these changes at Soft Garden, which feels surreal now. It's not like we made the biggest breakthrough or whatever. We're still there, but it's really a good feeling when you know that, okay, we are on the right direction, yeah. And the mean time to recovery, what happened maybe, I don't know, a year ago at Soft Garden, I pushed the change and yeah, I didn't know where it is. Like maybe when my team lead would deploy it, it would be ready, but I don't know. Like I continued, I picked up another ticket. I had no idea about where production was because it was a quite a split between ops and devs, right? So we need to involve people and allow them to actually be engaged in production, but also give them the tools so they don't screw everything up, right? We need to allow that the automated tests increase the confidence. So in the end of the day, we are all human, right? We'll make mistakes, but when you have such strategies in place, they can just help you. And then change failure rate. Just write more tests. No, not really, but write good tests, yeah? And if you're scared still, just put it under a feature flag and it should be fine. You can turn it on when you think it works. And the last one, which is the 3 ways of DevOps, optimizing the flow of work. This is from left to right, from devs to the operations, basically having a good CI/CD pipelines, also visualizing work. So I don't know if there's a company who doesn't use a Kanban board or whatever, but when you have the work that you need to do visualized, you have a different feeling, right? The second way would be having feedback loop. So after it's published to the users, we need feedback so we can improve it, right? Maybe we missed something. So the next iteration, we do that. Also, I missed in the first optimizing the flow of work. It's also having a shorter iteration. So now you know what I mean, like having sprints, having CI/CD, and being agile in some sense. Third way is actually a cultural change. So we need to change from within. Every person in the team has to be proactive, shout out to bad practices and help the team learn new things. As I just mentioned, at Soft Garden, we've set up a book club in our team that we meet once in 2 weeks, and we all read a chapter and then we just discuss it together. So this way, it's like you don't have to read the whole thing, but you understand the whole book, right? Yeah, and for the end, I came up with these 4 things that really make a team really succeed. If you have empowered teams, they can decide what they use, they know what to do, they actually are trusted. The customer feedback, we need customers to produce good products, right? So if we don't act on their feedback, we'll just build something no one uses. And working in small chunks. We've had this problem pretty recently at our company where we tried, like we were so confident that we would finish one feature that should have been split up, and then we just understood. So sometimes you learn by failing, and that's good because we need to allow teams to be courageous to make mistakes, but then they also need to learn from those mistakes. And in the end, as every company that is successful that we would all want to work for have these R&D programs, we don't need that. We need just to allow teams to experiment and have a trust that they will innovate, right? So for the end, because I'm now finished, I just wanted to suggest these two books. These things that I talked mostly, you will find those detailed stuff there because we only had 20 minutes. I'm pretty sure I couldn't put everything that I got from there, but I highly recommend them. So maybe we also talk about them later. And for the end, I would say, any questions?